Okay, we're doing 2-2B, pages 117 to 118, exercises 1 through 14 all. On 1 and 2, you're supposed to draw a figure to represent each situation described below and name the postulate it illustrates. So on 1, they are asking you to draw points R and S in a plane A. So if I were to draw a plane A, so there's plane A, and I have points R and S. There's R, there's S. So points R and S are in plane A. RS, line RS, is also in plane A. And there's the picture that represents the situation. Number 2, here they're saying there is some point F that is not in the plane containing points B, C, and D. Oh, by the way, on the number 1, that is called the flat plane postulate. The flat plane postulate. And the flat plane postulate states that if 2 points are in a plane, then the line containing the points is in the same plane. And that flat plane postulate you can find on page 116. Okay, flat plane postulate. Number 2, there is some point F that is not in the same points, not in the same plane as the plane containing B, C, and D. So here we go. There is a plane. Here is points B, C, and D. B, C, and D. There is another point F that is not in that plane. And this is the points existence postulate. Points existence postulate, which state that space contains at least every plane contains at least 3 non-collinear points. Every plane contains at least 3 non-collinear, that means points that aren't in a straight line, so in other words, what they're saying is that 3 points define a plane. 3 points, 3 non-collinear points define a plane. If you have 4 points define a space. Okay? So, but the description they gave, there are 3 points that are on a plane, the 4th point is not. Okay? So that's 1 and 2. Alright? For problem number 3, 3, 4, 5, and 6, determine which statement is true or false. If true, state the postulate or postulates that justify it. If false, state or sketch a counterexample. So number 3, they're saying that P lies in a plane B. P lies in a plane B. The line containing P and Q must lie in plane B. So, and you know that's going to be false. Okay, so let's draw the sketch. So that's false, first of all, and I'll show you why. So here is plane B. So there's plane B. Okay? And we have point P. Okay, so here is point P right here. Alright? And they say a line containing P and Q must lie in the same plane. Well, I can have Q here that's not in the plane, and that line could be running right through P and Q. Oh, that was really good, Jim. Let's try that again. Let's try that whole thing again and see if we can make it a little better. Okay. So let's go back to pen. Alright, so we have the plane B. Here we have a line with P and Q. And you notice that Q is not on plane B, but there's a line P and Q that have a line going through it. So there's a sketch of a counterexample. Okay. Number 4. States plane A and B intersect. Their intersection is a line, and that absolutely is true. If I take any two planes, if I say this is plane A right here, and then I say this is plane B, right here, their point of intersection is going to be this line right here. And that's the point of intersection for those two planes. So, and by the way, this is the plane intersection postulate. Plane intersection postulate. Which states, the plane intersection postulate states that if two planes intersect, then their intersection is a line.